You know, we do it dozens, maybe hundreds of times a day without even thinking about it. You type in a website, hit enter, and poof, it just appears. But behind that seemingly magical moment, there's this secret, lightning-fast conversation happening. So today, let's pull back that curtain and listen in.
So what is really going on in that split second? You click a link to watch a movie, and bam, the page is just there. It feels totally effortless, but what's actually happening is an incredibly precise and structured conversation. Let's see if we can figure out what they're saying.
You know, from our side of the screen, it's just a simple three-step dance, right? You tell the browser where you want to go, you hit the launch button, and you arrive. That's the magic we all see. But the real magic, well, that's in the part we don't see.
Yeah, that magic is really just your browser sending a very formal, very specific message to a server somewhere out on the internet. It's less like a magical spell and a lot more like writing and sending a carefully structured letter.
And this is what that letter, what we call an HTTP request, actually looks like. I know it might look like a bunch of techie code, but it's really a language with pretty simple rules. Every single line has a specific job to do. It's basically your browser politely saying, "Hello, Netflix server, I'd like to see this specific movie page, please, and thank you."
All right, so let's put on our detective hats and decode this thing. We're going to go through it piece by piece to understand exactly what our browser is telling the server.
The very first line, right at the top, that's the most important one. It's called the request line, and it's got three key parts. First, get. That's the method, and it just means I want to get some data. Second, that long string of text, that's the path, the specific thing we're asking for. And third, HTTP/1.1. That's the language, the protocol that the browser and server have agreed to speak.
Now, the method we just saw was get, right? Which is for fetching information, like reading a web page. But your browser uses other methods too. The other big one you'll run into all the time is post. Just think of post as what happens when you fill out a contact form or type in your password. You're sending information to the server, not just asking for it.
Okay, next up we've got the host header, and this one is super important. See, a single computer, a single server, can host hundreds of different websites. So the host header is like putting the specific person's name on an envelope. It tells the server, hey, out of all the websites you're running, I'm here for Netflix.com.
Then you have this line, the user agent. Think of this as your browser's formal introduction. It says, "Hi there, I'm the Firefox browser, and I'm running on a Windows machine." So why does the server care? Well, it wants to send you back a version of the website that's perfectly optimized for your screen, whether you're on a huge desktop monitor or a tiny little smartphone.
The referrer header, this is the origin story. It tells the server where you were right before you made this request. This is the digital breadcrumb trail that lets websites analyze how people are finding them. But it's also a simple security check. If a request for a sensitive banking page comes from some random sketchy website, the server might get suspicious and just block it.
And finally, after all that information, we get nothing, a single blank line. It's so easy to just ignore it, but in the super precise language of HTTP, this blank line is a critical stop sign. It clearly tells the server, that's it, that's the end of my request. I've told you everything you need to know, the ball's in your court now.
Okay, so that's the theory, right? But talk is cheap. What if we could actually pause the internet for a second and see one of these requests for ourselves in the wild? Let's stop looking at diagrams and jump into a real-world scenario with a tool called a web proxy.
So using a tool like Burp Suite, we can do exactly that. We launch its special browser, we flip on the intercept feature, which is basically a pause button for our internet traffic, and then we just click a link to Netflix from a Google search. The second we click, bam, the request is caught.
And you'll notice something funny. The web page itself seems frozen, just stuck in limbo. It's not loading at all. That's our proof. Our interception worked. Our digital letter has been stopped mid-journey. It hasn't even reached the Netflix server yet. It's being held by our proxy tool, just waiting for us to take a look.
All right, now for the fun part. We get to see the real thing. Let's analyze the actual request our browser tried to send to Netflix and see how well it lines up with everything we've just learned.
And here it is in all its glory. Let's look at the evidence. The request line? Yep, it's asking to get the main page. The host? It's Netflix.com, just as we expected. The user agent says we're using Chrome on Linux. And the refer, sure enough, it shows we came directly from Google.com. It's all there exactly like we talked about. But hold on, if we scroll through the full request, we see something else. A whole long list of cookies. These are just little bits of data the server uses to remember who you are. It's how it keeps you logged in, how it saves your preferences. Now, that is a huge topic for another day, but it's pretty cool to see them right here in the wild. So, we've dissected the request. We've seen exactly what our browser is trying to say. Now, for the grand finale, what happens when we finally hit play and let this request finish its journey to the Netflix server? Okay, we go back to our tool, we turn the interceptor off, and we release the request. Our digital letter is now finally in the mail, speeding across the internet to its destination.
And boom, just like that, the Netflix homepage appears in our browser. The server got our request, it understood it perfectly, and it sent back everything needed to display the page. The conversation is complete, and this entire invisible dance happens in the blink of an eye every single time you click a link.
So we've seen the letter our browser sends out. We've decoded it line by line. But, a conversation is a two-way street. What does the server's reply even look like? How does a bunch of code get turned into the website we actually see and use? Well, that's the question we're going to tackle next time.